Hey friends, good morning. Today is 13th of December 2020. This has been an indifferent year, though it seems that a vaccine is around the corner. In my series of random thoughts out of my interest and long association with multi-beam systems, basically for our brilliant lot of young surveyors and survey tech, have been compiling a discussion on orientation in the incredible multi-beam systems and the factors influencing its image compilation. Now, I had been a part of Rezon 7125 training in Gravesend with Port Authority of London a couple of years back. This is just me sharing my information, training, and experiences. Although this discussion is not all inclusive and does not have the scope to provide a definitive response, well, it may yet shed light on some of the issues of our interest. Today, our discussion would be around transceivers, its making, the electronics, and the acoustics associated with it. Ceramics in steel or a titanium casing is mounted on a cork-backed material, and then it is covered with polyurethane just to protect it from damage and prevent any water ingress. Now this is then filled with oil to match the water pressure or for impedance matching of the transceiver. Now we are aware that ceramics oscillate to create isotropic waves. While we need a directional along track propagation for a multi-beam system, a single sound energy source would spread spherically, which from the multi-beam point of view is just a waste of energy. Hence, the multi-beam system has a projector that comprises of multiple ring ceramic arrays that suppress the side lobes, or it is for the side lobe rejection. Well, we are aware that transmitter at the sonar operating frequency generate voltage pulses. The piezoelectric ceramic projector responds to the applied voltage with oscillations, generating acoustic pings. The transmit beam has a pattern. It has a wide beam across the track and a narrow beam along the track, with maximum power going to the outer swath of the main lobe. So this is about the transmitter. Now let's come to the receiving part. The receiver array receives the acoustic echoes and reconstructs it. The process is just the inverse of the projector. It again uses multiple block ceramics. Each receiver channel is connected to its own electronic circuitry or a channel. Now the point to note here is that the number of channels in a multi-beam has no relation with the number of beams in a multi-beam system. An individual ceramic or a channel is not equivalent to a beam, but it's the beam width that depends on the length of the array or the aperture and the operating frequency. Now the point to note here is that each of the channel is excited by the acoustic returns from all the directions. So each channel uses the RMS value of the signal to determine the part of the signal of its own interest. The elements of an array are spaced half a wavelength apart. The more the elements or the channels used in an array, the narrower the beam width. So the relationship we can just make here is that along with that operating frequency, the number of channels determine the beam width, while the number of beams determine the swath width of a system.